So let's find the center of mass of a system of three objects here. In this case, these three objects have masses 3, 4, and 8 units, respectively, and they are located at the points -1, 1, 2, -1, and 3, 2. So let's start by sketching what this is going to look like. Let's see, 1, 2, 3. We have our three coordinates here, our three sets of coordinates. -1, 1 is going to be the point right here. This one has a mass of 3, so we're going to have 3 mass units right there. Then we have another point at 2, -1, so that's going to be here. This has a mass of 4. And finally, at the point 3, 2, right here, we have a mass of 8 units. Okay, so we have a system of 3 objects here. We are going to try to find the center of mass of all 3 of them. So what we do is we use moments. We're going to find the moment with respect to y by adding up the moments of each of these objects away from the y-axis. So right here, we have a mass of 3, and it's -1 unit away from the y-axis. Another way we can look at that is just to grab this value right here and multiply it by this value. So we're going to have 3 times -1 plus, then we do the same thing for each of the other values here. This one is 2 units away from the y-axis, or else you can just look at this point right here, 2, and it has a mass of 4. So we're going to have plus 2 times 4. There we go. And then finally, our last point here is 3 units away from the axis, and it has a mass of 8. So we're going to have 8 times 3 for this value here. So the total moment with respect to the y-axis is going to be -3 plus 8 plus 24 is going to be 29. Then the moment with respect to the y-axis, the moment with respect to the x-axis, the one we haven't calculated yet, these are now going to use the y-coordinates of each of these points to figure out how far they are away from the x-axis here. Now we're going to use all of the second coordinates in each of these, multiplied by their masses. So we're going to have 1 times 3, 3 times 1. We're going to have 4 times -1. And finally, 8 times 2. So we're going to end up with 3 minus 4 plus 16. That comes out to a total of 15. So now the actual centroid here, we can take each of these values and divide by the total amount of mass in the system. Well, the mass in the system will be 3 plus 4 plus 8 is 15. So the x-coordinate, let me again color code this correctly. I did this wrong before. So the x-coordinate comes from the moment with respect to y. The x-coordinate of the centroid is going to be 29 divided by the total amount of mass in the system. 3 plus 4 plus 8 is 15. So we get 29/15 for our x value, and then our y bar value can be found by taking the moment with respect to x, which is 15, and dividing by the total amount of mass in the system, which is also 15. So the y bar is equal to 1 here. So the coordinates 29/15 and 1 are going to be the center of mass of this system. 29/15 is just shy of 2. So we're looking at a point that's right about here. And it makes a lot of sense that this would be the center of mass because it's relatively close to the heaviest point, right? It's in between all 3 of these guys. You could imagine that this balance would be struck right about there. All right. So this is how we calculate moments and centers of mass for a finite number of points. In the next video, we'll talk about how we can extend this to an infinite number of points, and we're actually going to use calculus.